Hello again. Thanks you for watching and studying math with me. This video is about division of algebraic expressions. So, when the denominator is a monomial, the quotient of a multinomial divided by a monomial is found by dividing each term of the multinomial by the monomial and adding the results. Each time, exponents may be combined only if the base is the same. Let's look at an example of this. So, to solve this problem, I would divide the denominator into each term in the numerator. Now here 2 goes into 4 twice, the a's will cancel, and x squared over x is x, so that is 2x, minus 2 goes into 6 3 times, a squared over a is just a, and x's cancel, so that is the answer to that problem. Now, if your denominator is not a monomial, the division is similar to long division of numbers. Let's review that just to remind ourselves of how that goes. So suppose we wanted to divide 342 into 8,754. Well, we would realize that 3 goes into 8 2 times, and this is our trial divisor, and we will multiply around. 2 times 2 is 4. 2 times 4 is 8, and 2 times 3 is 6, and we subtract and we get 191. Since 191 is less than 342, we know we pick the correct trial divisor and we bring down the 4. And now we say 3 goes into 19 how many times? If we were to try a 6, we'd find out it is too big, so we will result with a 5. So 5 times 2 is 10, carry the 1, we get 5 times 4 is 20, and 1 is 21, and carry the 2, 5 times 3 is 15, and 2 is 17. So we will subtract and get 204. 204 is less than 342, so that is the remainder. The way that we're going to be writing these remainders in this class is this way. We're going to say that this is going to be 25 and 204 over 342. But we would like to have that in lowest terms. There's a 6 that will go into both of those. So 6 goes into 204. 3 for 18, so that is 34. So that would be 34, and 6 goes into the denominator 57 times. So the final answer to this problem will be 25 and 34 over 57. Let's do an example. So here we have this division problem. So 3x goes into 6x squared 2x times. Then I will take 2x times minus 1 and get minus 2x, and I will take 2x times 3x to get 6x squared. And now, as before, we're going to subtract. When you subtract, you change the sign of the bottom numbers and you add. So this will end up canceling out by design. This is going to be 9x. I will bring down the minus 3. Now I divide again. 3x goes into 9x how many times? And it goes plus 3 times. I will multiply around, and I will see that there is no remainder. And so if I were to check this, I could check that 3x minus 1 times 2x plus 3 is indeed 6x squared plus 7x minus 3. So this is the check that I could have done. Let's do a problem where we don't have a remainder of 0. Consider this problem. Notice that we insert a placeholder so we do not get confused about that term. Alright, so this will go 2t times, and I will multiply around. So I will get 4t, I'll place that under the 4t. I will get minus 2t squared, and by design I will get 6t cubed. Now I will subtract these by changing the sign of the bottom numbers and adding. Okay, 3t squared goes into 3t squared one time. And so I'll multiply around. I will get this. I will get this. And I will get, by design, 3t squared. Again, I'm going to subtract. That's accomplished by changing the signs of the bottom numbers and adding. And I will get minus 3t. Now that will cancel, and that will cancel. And that is now my remainder because t squared won't go into that. And so the answer then is minus 3t over 3t squared minus t plus 2 as remainder, and the whole answer is 2t plus 1 minus 3t all over 3t squared minus t plus 2. In class, we'll do several problems, but serious students will want to carefully read the section and examples and do as many problems as possible. Until then, remember, time is precious. Each day must count. Do the math. It will make you strong. Take care, and see you in class.